So we can use some restricted characters. We can use reserved base names. We can exceed max path. So we can give paths that are longer than 260 characters, which again is the maximum size for a path. Under certain circumstances. Sometimes it's 65,535, I believe, or somewhere close to that anyway. So we can violate max path, which again is handy for buffer overflows because a lot of application developers use max path as the size of a buffer, which is not really great because, as you can see, we can exceed it, and not many people know about that. So this helps us out a lot. And we'll talk a little bit about that in a second. Now, then we have UNCpads. The short UNC is nothing special. Basically, it's used to refer to like an SMB server share, an SMB share rather. So we can even use these to refer to files across the internet. As long as we're not blocked by anything in between, which unfortunately, or fortunately, depending on who you are, is generally blocked by ISPs and a variety of different people, routing your data through the internet. So this generally doesn't work terribly well across the internet, but it will work on a LAN basis quite readily. So nothing special there. But we can also tack on the minimal parsing prefix to it and have the same advantages as we had before, not having to worry about certain restrictions on our file names. This is what is known as long UNC. So nothing special, but it's important to talk about that because we'll be using it shortly. Then we have the AntiDevice namespace prefix, or NT-object namespace prefix. So these paths start with double whack, dot whack. And so we can refer to files on, we can refer to devices on the system with file paths. So for instance, we can refer to, if we have an AirPCAP card installed, it will have this shortcut, AirPCAP 00, or if we have multiple 01, 02, etc. The next one is a pretty interesting one. Global root is sort of the root for the majority of devices. And I could talk about the NT-object namespace a little bit, but there's a talk, NT-object insecurity, which will probably explain more. It's that sort of thing is a little bit outside the scope of this talk. So, but this refers to the first hard disk volume on the machine, which might be equivalent to C, the C drive. And the other thing is that it doesn't need an assigned drive letter. So let's say that you have some sort of machine with a recovery partition on it that doesn't have an assigned drive letter. You can actually access all the files on that as long as the file system is something that Windows can work with by using this path instead of, for instance, C:/ or whatever you do with the drive letter. So that's pretty cool. So we don't need an assigned drive letter to work with certain partitions. And we can also access other devices in a similar way. So instead of maybe D:/, we can use this path instead. And if you want to play around with the NT-object namespace, WinOpt from sysinternals will allow you to do that. So simple stuff. NTLM credential capture. Now, as I was mentioning before, a lot of applications will simply take a file path and pass it back to the operating system and let it return whatever it decides is coming back to the application. Now, if you pass it a UNC path, a path to a Samba share, frequently, and because Windows will handle this on its own, will go out and request this file from whatever Samba share, pull it back and return its contents. Even though the application may not have any networking code built in, even if it's just trying to open a file from the files from the operating system, it will make that request, and the operating system will make that call to the Samba share, pull the file back, and serve it up. So that's interesting. So even with applications that have no networking functionality, we may be able to force a Samba file share browse, trigger some sort of SMB client-side vulnerability, Maybe just capture the credentials if we're talking about until version 1 and then replay them against the host itself. So, not so great. So yeah. So the next thing that we can use the prefixes for is to do some directory traversal. If we have an application that filters out anything that starts with just a C:/, but we want to get to the C drive anyway, we can probably use any and or all of these. So great. And one thing you might notice here is the use of sort of loopback UNCpath. Now, interestingly, a colleague of mine recently presented at Black Hat DC 2010 about a flaw in Internet, or several flaws in Internet Explorer, which allowed you to, as a web server, request and get any file off of the user's file system. And it involved using these UNCpaths in pretty much exactly this way, because Internet Explorer would say, oh, well, this is a UNCpath, this is an intranet sort of thing, so this is a trusted thing. So let's pull this back, and then once it was loaded into the context of the document object model, it could be pulled from there back to the web server. So that's no good. And again, as I mentioned before, the buffer overflow with paths exceeding max path. We can make some Windows rootkits deadlier. So imagine you're a Windows system administrator, and one day you find a file called con in wherever. So you try to delete it in Windows Explorer, and Windows Explorer says, no, I can't do that. And that's the funny thing about these files with reserved base names that you can create with a minimal parsing prefix, that double whack question mark whack, is that the majority of programs just simply can't touch them at all. So Windows Explorer even won't be able to handle this file. So you try to use this file, this file named con, and Windows Explorer is like, no, I don't wanna. And so then you try to open a Notepad, and Notepad's like, no, I don't wanna. And so you try to, look at it on the command line, and your command prompt seems to hang because you're actually accessing the console, and then you cry and pretend that it doesn't exist, or that it's part of the operating system, or that one of your applications put it there and it's probably just fine. So we can make, files very hard to delete. Now, what's really interesting about that is when you start to talk about this in the context of antivirus systems. I cannot yet disclose which antivirus systems are vulnerable, but of some 30 that I tested, more than 20 were vulnerable to this sort of problem, where you create a file with either trailing characters that are discarded, because when you go to refer to that file and access that file, your request for that file is going to have periods and spaces at the end of the file name. And Windows is going to go, oh, let's get rid of these. Well, I didn't see any file with that name. Sorry, no dice. So that's going to be hard to access too, and you're going to need to use the minimal parsing prefix to refer to that file as well. So anything with reserved base name or these illegal trailing characters can be used to produce some interesting responses with antivirus systems. The least interesting of which is that the file may need to be deleted after a reboot, or maybe can't be deleted at all. The most interesting is that some will, especially with the reserved base name stuff, will try their best to get the contents of this file. And things like con or LPT or whatever are never going to send an end of file. So this process, this AV scanner, is going to just sit there and wait for this end of file from this file and hang and become entirely useless. Some antivirus systems won't even touch files with these strange names, won't even scan them. Maybe we'll say it did scan them, but actually didn't. Or just refuses to scan it at all, believing that it's not there. So we can bypass antivirus systems with these techniques as well. So yeah. Oh, one more thing. I never talked about how we can mess around with file permissions.